never both.
Literally. Quantum physics be like, actually nothing makes sense.
So simultaneously passes
The PowerPoint presentation
with the detectors
moment.
present.
Yeah.
But when we open our eyes and look, we always
Okay.
see the detector indicating that the marble passed through only one hole or the other. Never both.
But then the math tells you the opposite because it's been both.
This
Alright,
means
what's this
that the
channel name
marble
called?
must be more than just a wave.
Science physics videos by Eugene.
The wave only describes the probability of where we will see the marble when we look at it.
Yeah.
The probability of the marble being at a particular location is given by the wave's amplitude. The higher the amplitude of the wave at a particular location, the higher the probability is that we will see the marble there when we look. This means that we can never simultaneously know both the
The cat
position
is trying
and
to
the momentum.
manipulate our brain.
Before the wave hits the detector, we know exactly what direction the momentum is in. However, we know nothing about the object's position.
The cat is terrifying.
Immediately after we see the marble hit the detector, we know exactly where its position is. But now we know nothing about the direction of the momentum. Not only are we not able to simultaneously measure the position and momentum of an object, the object does not even have a specific position or momentum until we observe it. If the marble always had a specific position, then the marble would not be able to go through both holes simultaneously, which is necessary to produce the striped pattern.
Oh.
Quantum physics be like,
But
ugh.
if all objects are just a wave of
What is
then this means that the detectors and all the objects the marbles interact with are just a wave of probability too.
Die.
Suppose we place an object behind each of the two holes.
Bless you.
The marble will knock down one of the two objects, depending on which hole it passes through.
Pulling animation tips, yeah.
If we close our eyes and don't look, then the wave of probability passes through both holes, and each object being knocked down also becomes a wave of probability.
Huh?
Yep.
Just as each marble simultaneously passes through both holes, each object is now simultaneously both standing up and knocked down.
Huh? Schrodinger's
Yep.
cat kind of thing.
No matter how long we wait after the marbles have hit the objects, each object will continue to have a probability of still being in the standing position. And each object will also continue to have a probability of being in the knocked down position. According to the mathematics describing the probability waves, neither outcome is certain. It's only when we open our eyes and look that we see only one outcome or the other.
โอเคเข้าใจแล้ว It's silly. Silly.
So silly, this is real life.
Why? It's like. What
It's not just that we ourselves do not know the outcome until we look. It seems that even the universe itself does not know which object is standing up and
Oh, what
which
is that
object is knocked
frequency?
down until we actually open our eyes and observe the results. To explain why this is the case and what this means about the fundamental nature of our universe, let us talk about spin.
Things
The
spin.
direction of the spin of a particle can be described by an imaginary arrow. Particles spinning in opposite directions will have their arrows pointing in opposite directions.
Yeah. Alex, on this?
That's the only thing I get.
This is like, why get this one?
Particles are too small to see the spin directly with our eyes, but can build detectors which tell us if the spin is in the direction of the red plate or if the spin is in the direction of the blue plate.
Too many to each.
Good for you. Make the sound.
Suppose we think that we already know the spin of a particle ahead of time, because we have measured it previously, and we line up the detector with this direction. The detector will always give us the same result we measured previously. But if the spin we measured previously is not in the same direction as the detector, then the act of measuring the spin ends up changing it. It is not possible to simultaneously measure the spin of a particle in more than one direction at a time. If we want to know the direction of the spin in the horizontal direction, then we need to rotate the detector.
Why not make a box? Oh, have you heard of Michio Kaku?
Huh?
He's an
But why does this
astrophysicist.
mean that the
Oh,
universe
I
does
heard.
not know what an
I
object
love
is
that guy.
doing until we observe it?
I've read his book. One of them. His name. Hello.
I've only
The
watched
answer
his
lies
YouTube
in the
videos.
fact that we can produce pairs of particles that always spin in
Watching
opposite
physics
directions.
video. Just
Well, I just like the
If the two
It just
detectors are
explains
aligned
why
in
we're
the same
stupid.
direction, the spin of one particle is measured to be towards the red plate. The spin of its partner is always measured to be towards the blue plate. This is true 100% of the time.
It's just nerds watching.
This is still true the vast majority of the time.
This
even
is
if
the
we
kind
offset
of
the detectors by
entertainment that
45
Mac would
degrees.
really
Yes,
enjoy. Yes, innit? Huh?
I used to, but no, not anymore. Not anymore.
By 45 degrees,
Because you've
when
learned it
one
all.
particle
No.
is
Oh,
towards
what?
the
No.
red plate,
What
the
have you
partner
found
will be
entertaining
towards the
for
blue
you
plate
now?
the vast majority of the time.
Not
there's
really,
Tetris.
not really sure.
You know, I used to play Tetris in my head, yeah, but it's in 3D. I used to lie in bed,
And they
yeah,
are both
and then
identical.
imagining playing Tetris in my
Oh.
head, but it's in 3D.
3D.
Not just the 2D version.
Oh.
Towards the blue plate.
Yeah.
Can I have some cake?
If the universe knows ahead of time that the spin of the second
Can you have
particle
some cake?
is the red plate,
I saw
That's
cake in the
not-
fridge.
I know, that's not birthday tomorrow. Oh,
probably be towards the red plate.
yeah,
Even
tomorrow
if we
you can have some
rotated
cake.
it by 45 degrees, either into the vertical position or into the horizontal position.
So stupid. Good job.
ไม่เข้าใจ
เอาแน็ก explain
You want us to explain this?
understand
If the
this
universe knows the diagonal observation ahead of time, then the universe would
It's
also
just a
know
cat
that
looking at
one
balls, but
detector will be
no
rotated into the
one
vertical
understands.
position, and the other detector will be rotated into the horizontal position.
No,
The
I
two
think-
particles will still probably
No,
be
those are the
spinning
real
in
ones.
opposite directions. But when we actually do the experiment, this isn't what happens. When the two detectors are offset by 90 degrees, there is no correlation between the measured spins of the two particles. When the two detectors are offset by 90 degrees, the spins of two particles are just as likely to read in the same direction as they are to read in opposite directions. Therefore, if we start out by
it's in my
assuming
hair.
that the universe knows ahead of time what the measurements will be, this leads to a contradiction. Assuming that the universe knows the answers ahead of time implies that most of the time, the measured vertical spin of one particle must be in the opposite direction of the measured horizontal spin of the second particle. But we know that this is not the case. The apparent implication is that the universe cannot know ahead of time what the measurement of the spin will be, and the universe makes up its mind only when the spin is actually observed. The apparent implication is also that when the spin of one particle is measured, it sends an instantaneous message to its partner to spin in the opposite direction. If each particle makes up its mind about what direction it's spinning only when it's observed, then we need this instantaneous message from one particle to the other in order to guarantee that the two particles will always decide to spin in opposite directions when the detectors are aligned.
So then it comes in string theory, they all connect.
This is true no matter how far apart the two particles have traveled away from each other. Even if we wait until the two particles are on opposite sides of the universe before we make our observation,
Wait, so what if
this
there's
instantaneous
aliens
message still seems to occur.
and they measure a particle and it travels far
Until
away and
we
it
observe the
reaches
particles,
us,
Their spins are nothing
and
more
then
than
obviously its spin is
probabilities.
decided.
But we need
I wonder
to
if that
observe only
changes anything.
one of the two particles for both of them to simultaneously decide in what direction to spin.
It
Because
changed.
it's already decided, right?
If everything in the universe is made out of these particles, including the detectors
But then it's like
themselves,
when you.
then the detectors are also nothing more than a probability.
But then it's
until
like
they are
if you
observed.
have the detectors in a certain like position,
According
then they
to the
kind of the
mathematics
spin
describing
tends
the
to like
probabilities
move
of the particles,
to that position, right?
passing through the detector is
So it
not
doesn't-
what causes the particles spin to
This is
decide
so
to spin
confusing.
in one direction or the other.
I don't know it either.
Passing through the detector entangles the detector to the particle, in the same way that the two particles are entangled to each other. The moment we look at the detector, it seems to send an instantaneous message to the particle, so that the detector's measurement will agree with the spin of the particle. This is the same way in which the two particles seem to send instantaneous messages to each other. There are many possible explanations as to what's actually happening, and how to interpret these results, and this is a matter of considerable debate. But if we really do have these types of instantaneous messages, which are faster even than the speed of light, then this creates an interesting situation with Einstein's theory of relativity.
In the car.
According to Einstein's theory
Elisa,
of relativity,
In the
different
car, in the
observers
car.
will
Lisa.
disagree about which event happened first, and no observer is more correct than any other. From one observer's point of view, the right particle was observed first and caused the left particle to change its spin. From another observer's point of view, the left particle was observed first and caused the right particle to change its spin.
This is actually giving me a headache. I feel so stupid.
Therefore, we can't know which of these events is the cause and which of these is the effect, since
Wait, so
both
was the
points
cat
of
in the
view are
car?
equally valid.
Further away from them and moving.
In
Oh,
fact,
cat.
according to quantum mechanics, we can't even know which particle is which. Suppose we have two particles in a container. Each particle does not have its own separate probability wave. There is only one probability wave, which describes the probability of measuring the two particles in every possible combination of positions. The probability that particle 1 will be in one position and that particle 2 will be in another position is exactly equal to the probability that the two particles will be in the swapped positions.
Now I understand why physics.
Therefore, we cannot
physicists
know
are
if
so
a
sad.
particle we're observing is the same
Imagine having to
particle
do this
we
for
measured
everything.
earlier.
Imagine
If
having
we
to
think
write
of
a
our
paper on
container
this and
as the
explain it to
entire
someone.
universe,
Mm.
then this would imply
Even
that
this
the
person's
universe
from England.
consists of just
I'm
one
such
probability
She's
wave,
doing well.
governing the
I know.
probability of
And
all
then
particles'
it shows that I
existence.
don't understand anything. It's so weird.
But if we ourselves are made out of these exact same particles, then why is the
Watermelon.
act of us observing something so fundamentally different from everything else in the universe? This is one of the greatest unsolved scientific and philosophical mysteries of all time.
Okay, easy.
Okay.
Easy. Do ball.
Yeah, to ball. I need something stupid to filter my brain.
Use